So before we graph our first logarithm, let's take a look at that exponential, 2 to the x. I've been saying all chapter that logs and exponentials are inverses. So if we go back a chapter and try to think about what we remember about inverses, the tables should flip-flop. If -1, 1/2 is part of the original, then 1/2, -1, will be on the inverse. Likewise, if 0, 1 is on the original, then 1, 0 is on the inverse. And if 1, 2 is on the original, then 2, 1 should be on the inverse. Note that if I connect those dots, I do wind up with a reflection over y equals x. That's what we expect our inverses to look like, reflections over that identity function. So this is what we would expect log base 2 to look like. Let's see if that's what we get. So again, I'm looking at log base 2. We could have done any parent logarithm, log base 3 for a common log, or log base e for a natural log. I'm sticking with log base 2 because we're more comfortable with our powers of 2 than any other logarithm. So the first thing to note is if I let x be 0, we can even pull up our calculator there to play around with that. If I let that x be 0, we get an error, because we're not allowed to put 0 into our natural logs, any of our logs, in this case log base 2. So I can't have 0, I can't have any negative numbers, so we're going to have an asymptote there. After that, though, our powers of 2 can help us out. So if we put a 1 into that x, log base 2 of 1, that's asking what power can I raise 2 to in order to get a 1. That's just 0. If I put a 2 into x, that's like asking what power can I raise 2 to in order to get a 2. Well, that's just 1, because 2 to the first power is 2. Now, if I try to put a 3 into this function, I get back a pretty ugly number. Let's go ahead and do that. Log base 2 of 3 is not very clean. But log base 2 of 4, again, 4 is a power of 2. So what power can you raise 2 to in order to get 4? Oh, 2. So 4, 2 is on this graph. And last but not least, we can get 8, 3 to fit on this graph, because 2 to the third power is 8. Keep in mind, we're not allowed to go past that asymptote, so we'll have a graph that hugs that asymptote and swings out that way. So that is our parent logarithm graph. Again, I could have picked any base. We're just going with log base 2 because we're more comfortable with those powers. Keep in mind, that does look like what we expected. We expected that nice inverse picture, and we got it. So note that the domain here is not all real numbers. I can't put in 0, and I can't put in negatives. So that's going to change things up a bit. The domain starts at 0, but 0 is not included. I can go from 0 all the way out to my positive numbers. No negatives allowed. My range, on the other hand, is where the all real numbers comes in. So note that there's a flip-flop there between the exponential and the logarithmic function. Additionally, like we said before, transformations are going to work the same regardless of the function you're looking at. So I can actually paste all the stuff that I put up for the last section. We just need to line it all up. So now K is our up and down, just like it was last time. H is our left and right, just like it was last time. And A will be reflection, stretch, and compression. Don't you wish you had a smart board? They're glorious. So again, we get all the same transformations we know and love from every other function we've tried to graph. Good times. Let's take a look at one basic transformation, and then we can take a break. So let's look at this one. We've got a +2 on the inside and a -3 on the outside. So that gives us two transformations. The +2 on the inside tells me this thing will shift to the left 2. The -3 on the outside tells me that this thing will shift down 3. That was an ugly down. So keep in mind we're talking about a logarithm here. So we still want that asymptote in the picture to help us figure out where the arrow should go. But now it's a vertical asymptote. So I want to use that left or right value to help us determine where it goes. So to the left 2 is going to give me an asymptote at x equals -2. So that's our new vertical asymptote. That's the line that our graph is going to hug. To get the rest of our points, I recommend using the calculator. In that y equals menu, we can get rid of that exponential graph because we're done with them for a while. Alpha F2 brings up our log base menu, and I wanted log base 2 of x plus 2 minus 3. Just like with exponentials, we'll see a few ugly numbers. We'll also see some errors, because remember the domain is no longer all real numbers. Don't freak out when you see those errors. They belong there. We do get a few good numbers, -1, -3. Oh, we also got 0, -2. And we got 2, -1. If we scroll down further, we should find one more that fits, do we? Yep, 6, 0. So there we have 4 good points that do fit on our grid. So we want to make sure that we hug this asymptote, but don't cross it, and connect the dots. I missed one of them, but it'll do. So remember, the domain here is not all real numbers, because I'm not allowed to use -3. I'm not allowed to use -4. Let the picture help you. The domain starts at -2, but we're not allowed to touch -2, so I have to use this symbol, no equal to bar. So x has to be greater than -2, and it goes all the way out to infinity. The range, on the other hand, this graph can touch any y value it wants. So all real numbers. So make sure you understand where these points are coming from, how the asymptote helps us find domain. Make sure you get what's going on before we take a look at the next 2 examples. I do want to do one more quick and easy transformation, as well as an ugly one with a reflection. So let me know if there's anything you need. Otherwise, I'll see you soon.